So here we need to verify that the given sequence is a harmonic progression and also find out its nth term. Let us begin. So what we'll do, so let us first try to prove that the reciprocal of each term, so the reciprocal of the first term will be 3, reciprocal of the second term will be 11 over 3, reciprocal of the third term will be 13 over 3, then we have 15 over 3 followed by 17 over 3. So let us suppose that this particular sequence is a arithmetic progression. But to show that, we'll have to first find out the common difference. So we have the second term, which is 11 over 3, and from it we subtract the first term. So 11 over 3 minus 3, that's going to be 2 thirds. Let's confirm this by subtracting the second term from the third term from the second term. So we also get 2 over 3. Then we have 15 over 3. This is the fourth term. From it, we are subtracting the third term. So we get 2 over 3. And then we have 17 over 3. That's the fifth term. From here, subtracting the fourth term, which is 15 over 3. So we get 2 over 3. So in each of the case, we see that we have a common difference d of value 2 over 3. The first term of this particular arithmetic progression is 3. So this is a arithmetic progression. So we have showed that the reciprocal of each terms of the given sequence is an arithmetic progression. If it's true, this must follow that the reciprocal of each term, that means reciprocal of each terms of the arithmetic progression, 1/3, 3/11, 3/30, 3 over 13, 3 over 15, 3 over 17 is a harmonic progression. So it must be true. Okay, now let's try to find out the nth term of the arithmetic progression. The arithmetic progression, the nth term, which is an, that's given by the first term plus n minus 1 times the common difference d. What is a here? A is 3. So be careful. We have to consider the arithmetic progression, not the harmonic progression. 3 plus n minus 1 times the common difference. So that's 2 thirds. So this will be equals to, so we have 3 plus 2n over 3 minus 2 over 3. So we have 2n over 3 added to 7 over 3. Fine. So this is the nth term, but we have to find out the nth term of the harmonic progression. So let's rewrite an as 1/3 multiplied to 2n plus 7. So therefore, finally we can say the nth term of the harmonic progression, that will be simply the reciprocal of the nth term of the arithmetic progression, 1 over an. So that will be 3 divided by 2n plus 7.